Hi, I'm Jasper and this is my ISP. It's called the LED Zeppelin or LED Zeppelin, and what it is it's a game. What you have to do in this game is push this button when this light is on. If you push it when it's off, you lose points. If you push it when it's on, this bar graph will slowly go up. However, it is very difficult. What you do is first, you turn this on using this switch right here. As you can see, this LED now flashes about twice every second. And then you have a choice right now. You can either have this on, which it is right now, and what it does when it's on is it has penalties. So it means if you push it at the wrong time, if you push this button when this is off, then you lose points, and this goes down. However, it's at 0 right now, so you can't lose any more points. If you turn it off, like this, then that means when you push this, when this is off, nothing happens. If you push it when it's on, it goes up, meaning you can pretty much hold it. So, and then you have this potentiometer, so you can change the difficulty. So if it's really low, as it is now, it means when you push this button, it'll go up really fast, and if you switch this the other way, it will actually go down very fast, and it will go back up because of how easy it is to get points. If you push it really, as you can see now, really hard, and you push this when it's off, it will go up very slowly. And if you put it back on, you push it, it will go down and it won't go back up. So the point of the game is you would normally have it about here, because it's such a hard game. And what you do is you try to push this button at the exact time that the light goes on. As you can see, I did it at the right time, the light went on. So that is the main point of the game. Now if I turn it off, I will show you the circuit really quick. This is the circuit. It's just in a little bit of acrylic and hot glued together and bent. It's a pretty nice circuit. It's still on the breadboard, and I can explain it much better using this schematic. This circuit is comprised of two main parts. This part right here and this part. This is a NAND gate oscillator. Exactly what we did in the last project. It puts out a square wave, 2 every second, so 2 hertz, and you can see that quite clearly. It's demonstrated in this LED, which flashes twice every second. Whenever this is high, this is on. That's why this gives a great indication of when you're supposed to push your button. This is the most important section of the circuit. What this does is when this is on, this LED, which means this output is high, you're supposed to push the button. If you push it when it's high, that means this output right here is high, because when this is high, this is low. When this is high, this is low, making this high, meaning this LED is on. When it's high and you push the button, the power flows through this 22k ohm resistor and into this capacitor, which holds the power and turns on the base leg of this NPN, which then activates this whole section of the circuit. I actually moved this 22k resistor. I removed it and put in a potentiometer because I found the circuit too hard, so you could change the difficulty, as you saw before, from up to 10k instead of 22k, because I found that too hard. Because this is a capacitor resistor combination, so that would change the speed and how much each correct button push changes the LEDs, so how much power goes into this when you push the button at the correct time, which changes how fast these LEDs will light up. So when this has enough power, this capacitor, it presses this the base leg, and slowly it will go through the resistors and turn on one by one the LEDs, and that's how you know you're doing well in the game. If you push this button at the wrong time, that means this is low, and the power flows from the capacitor through the potentiometer, which is which is here instead of the 22K. It flows through that in to ground into the output, which is the same as ground when it's low, and you lose power and your LEDs go down. So that's the basic outline of my circuit. I hope you like it.